So we were looking at this question. Is this a vector space? We know that for a product of two numbers to be positive, the two numbers must either be positive or both negative, which corresponds to the first and third quadrant. So let's take two vectors from these two quadrants, 4, 1 and -2, -4. Let's add the two and we get 2 and -3, which lies in the fourth quadrant. So it is clearly not a vector space as it is not closed under addition. We saw what closing under addition means in the last video, so if you haven't checked it out yet, please do so. Here's another question. If S is a linearly independent subset of the vector space V, then any subset of S is linearly independent. I think this one you can easily conclude to be true. For example, if 5 vectors are linearly independent, then any subset of those 5 vectors would obviously be linearly independent, as there is no linear combination that can produce those vectors. Here's another one for you. Take your time and understand the question well. The keyword here is maximum. We know that a space of Rn has n linearly independent vectors. This means here the p vectors form the basis of the vector space, and we know the basis is the minimal set that spans the space. So a set having fewer than p vectors can just never span V. Let's see if we can solve this one. It says a set of 5 vectors in R4 is linearly independent. Well, as we saw earlier, we need only n linearly independent vectors for a space of Rn. Therefore, we can only have 4 linearly independent vectors in R4 at once, as the fifth vector will always be a linear combination of the other 4. The set automatically becomes linearly dependent. Okay, what about this one? A set of 4 vectors in R5 is linearly independent. Well, they can be and they can also not be. It's not necessary. We need more information about the vectors themselves to come to any conclusion. When the number of vectors is less than the dimension of the space, we can't be sure. But when it is more than the dimension, it is always linearly dependent. Feel free to ask in the comments if you still have any doubts about vector spaces from what we've seen so far, and I'll try to address them in a video. See ya!